Okay everybody, in this video I want to explain how to take a data set like this of these macroinvertebrates and how to calculate the pollution tolerance index and the water quality from these numbers. So take a look at this example here. This is what a class has come up with. They found 8 cranefly larvae and 15 crayfish, and you guys can see all the rest of this. The first thing you have to do is take this data just the way it is and enter it into that sheet that I've provided to you. Now, I've already gone ahead and do that just to save some time. So it looks like this. Okay, so if we look, they had 8 cranefly larvae, 15 crayfish. Okay, so here we have 8 cranefly larvae right here, 15 crayfish. I just went ahead and just entered all of that data. The second thing that we're going to do is we need to figure out up here where it says rare, common, or dominant. And I'm talking about right up here. We're going to use this information. So, what we need to do is, we have 9 gilled snails right here. Okay, well, because that's between 1 and 9, that's considered to be rare. So I'm going to write the letter R right here because that's considered rare. Next, we have mayfly nymphs. There was 100 of those. Well, if you look up here in this highlighted part, 100 or more is called dominant. So I'm just going to put a D here. For the water penny larva, we saw 53. That's between 10 and 99, so that's considered common, so we'll put the letter C here. 88 stonefly nymphs, that's between 10 and 99, that's also common. 11 hellgrammites, that's between 10 and 99, so again, that's common, we'll put a C here. Aquatic sobugs is 4th between 1 and 9, so that's rare. Cranefly larva, there was 8, again, that's between 1 and 9, so they're telling us that's considered rare. 13 fish fly larvae, that's between 10 and 99, so we consider that common. Put the letter C here. And 15 crayfish, that is common. It's between 10 and 99. 10 aquatic worms, that's between 10 and 99, we'll consider that common. And then midge larvae, there was only one of those, that's between 1 and 9, that's considered rare. Okay, so these values of rare, common, and dominant, those are provided to us. Now the organisms we did not see, you just ignore them. Okay, they didn't exist in this sample. The next thing that we have to do is use these rare, common, and dominant designations to do some math to determine this, the score that we're trying to calculate. Let me get rid of some of these. So up here, group 1 sensitive, they want to know how many times we marked a group of organisms as rare, how many times we marked a group of organisms as common, and how many as dominant. So come back here. Group 1 sensitive, that's this top part. Well, if you take a look, we only have one group of organisms considered rare. Okay, we're ignoring the 9. We have one group of organisms that we called rare. So back over to this, we have one group of organisms we called rare in that group 1 times these multipliers. So 1 times 5 is 5. Let's come back here again. Up here in group 1, we called 1, 2, 3 groups common. Ignore the other numbers. 3 types of organisms were designated as common. So back over to here. 3 were designated as common. 3 times 5.6. We should get 16.8 here. And then how many did we designate as dominant? Just the one, the mayfly nymphs. So one group was dominant. So 1 times 5.3 is 5.3. And if we add these up, we enter this here for the sum of index value for group 1. We got 27.1 because we had added up those 3 numbers. We do the same thing for the group 2 and the group 3. So group 2, we saw 2 things designated as rare, 2 designated as common, and none designated as dominant. So we had 2 rare, 2 common. So 2 rare, 2 called common, and none called dominant. So 2 times 3.2, 2 times 3.4, and then this is a 0. Okay, and that's what we did. Same thing we did for group 1, just with the other numbers. And this will continue for the group 3. So group 3, we saw 1 designated as rare, 1 designated as common, none were called dominant. So come over to here. 1 rare, 1 common, none that were dominant. So we get 1.2, 1.1, this is a 0. So here we get 2.3. To get this number down here, we add up these 3 sum of index value numbers. Okay, so we get 27.1 from group 1, 13.2 from the group 2, 2.3 from the third group. We'll just add these together. And we get 42.6. So I'm going to enter this down here. Now that number really has no context. So on this sheet down below, we'll get some ranges here. Okay, so our water quality score was 42.6. And then we look at these ranges, and where does it plug in? Well, 42.6 is above 40, so we would say that this water quality is good. So that's how you go through the numbers, and that's how you calculate these PTI values, these water quality scores, and I hope that was helpful to you.